This is part B of the demonstration, so I'll be showing the yaw angle tracking of the fish's body using the MPU 6050 gyroscope. Yaw refers to the horizontal rotation or the turning of the fish left and right like a weather vane. So the fish would be mounted on a pole, but it's sitting on the paper right now, and I've added printed angle markings underneath. The yaw angle is calculated by integrating the gyroscope's z-axis output over time, which gives us a real-time measurement of the fish's rotation relative to a starting point. As I rotate the fish clockwise, you'll see the yaw angle increase on the serial monitor. So before I demonstrate the yaw angle readings, I want to acknowledge the limitation of the gyroscope, which is drift. So you'll notice even when the fish's body is completely still, the angle continues to change, usually at a rate of 1 degree per second. So I'll show that here. So the fish is completely still, and we'll get the serial monitor started. And the angle's increasing even though the fish is staying still. This happens because the sensor isn't measuring absolute angle, it's measuring the angular velocity. So to get the yaw angle, we integrate the z-axis gyro readings over the time. If the sensor has even a tiny bit of bias, like reading of -1 degree per second when it's still, that error accumulates over time and causes drift. To address this, I've tried several software-based drift connection techniques, but while some of them improved the accuracy, they also introduced a new problem where the serial monitor would just freeze constantly. It made it pretty impossible to reliably demonstrate the angle tracking. So for the purpose of this demonstration, I reverted to a more stable version of the code that doesn't involve automatic drift correction. There's a small amount of drift, but it runs reliably and gives an accurate representation over short periods. So if I hit the reset button here and move it 45 degrees, it hit 45 before it starts taking off again. And then I'll rotate it around to 90. And then if I take it back to where it began, it sits at about 40, which is just showing the amount of drift. So just to show that again, reset at 0 and round to 90, and then back to where it began and reset there. So those angles sort of show that it closely matches the rotation. This setup's stable enough to match short-term angular changes. If needed, I can manually reset the device by pressing the reset button on the Arduino, just here.